Now let's talk about the Markov chain Monte Carlo. I hope you still remember what we learned about the Markov chain, right? Okay, here is the limit theorem for Markov chains. That's the main theorem we're going to need for our MCMC, Markov chain Monte Carlo. Definition: given a Markov chain transition matrix P, we say that state J is accessible from state I if there's a P's power ij is bigger than 0 for some t. State I and state J communicate if J is accessible from I and I is accessible from J. So basically, accessible just means that within finite time, you can always starting from I and goes to J with some finite time. Okay, and definition: we say that a Markov chain transition matrix P is irreducible, or all pairs of states in the irreducible if all pairs of states in the state space communicate. Okay, so we already explained what is reducible Markov chain, right? And if it's not reducible, we call it irreducible. So we already learned irreducible before. Okay, now this is the most important theorem. It's called the ergodic theorem for Markov chain. Let P be a irreducible transition matrix having a stationary distribution pi. Okay, we can choose any arbitrary starting state for the Markov chain. Let's say x0 equal to I, and then we have this thing. So let me explain what's that. For all the j, this is true, right? This just means that we have an indicator I. The indicator function I is the function that if xt equals to j, then this whole thing equals to 1. Right? That's an indicator. If xt not equal to j, then this thing equal to 0. Right? So this actually basically means that if you run this Markov chain n times long, and we're going to count how many times xt equals to j. Right? You count the proportion of x equal to j and divide it by the whole length of Markov chain n. Right? So this is basically means that the proportion of the Markov chain equals to j when n goes to infinity, that proportion will converge to the stationary distribution where the probability for j. Okay, we know stationary distribution pi is a row vector, right? This is actually just the probability for j in the stationary distribution. Okay, now for more generally, this indicator function I actually can be any function f. Okay, it could be xt squared, could be any function. Here is just a function of indicator where xt equal to j, but you can change to any function f. Okay, so if you change that to any function on f, then this limit will actually converge to the expectation of what function f of x. This expectation is calculated with respect to stationary distribution pi. Okay, for example, how to calculate that? So you see, this expectation just equals to, you take summation of a function f on j and times its corresponding probability in the stationary distribution, and then take the summation over all the possible j. Okay, so this is the most important theorem that we're going to make use in our MCMC.